Hello.
Morning, morning, people.
Good morning.
Hello, good morning.
Good morning, Francesca. Let's see, Glenn is around. Although obscure, yes, a little bit obscured, but you're there.
Failing to turn my camera on.
Hi, Glenn.
Hi.
Hi, morning.
How is everyone this morning?
Oh, right.
Full of optimism. We are now going to write a paper, right?
Absolutely. Yeah, so thanks, Valerie, for doing that literature searching.
Well, it wasn't as helpful as I hoped it might be because there's just so much out there. And I think most of it is going to be applications, but it's hard to spot, you know, the things that if we think that this paper is really concentrating on fairly generic sorts of modeling, it's hard from a title to judge, you know, whether they're really going to do anything very much.
Yeah.
Short of looking at them all, it's fairly hopeless. So then I just thought the other route might be to actually think about what was in the previous papers, and try and say a little bit about, you know, the common themes then and what's happened since, if we know what's happened since, or if nothing's happened, maybe say it hasn't and why it hasn't.
No, there are two themes. One is what has happened in these last, how much is it, 6 years or 5 and something years? Has there been development in the art of modeling as such?
Yeah.
That's a good question. And the second one is about COVID, really. Was the modeling that we have or adequate for dealing with COVID, or what is missing or was missing, or and that's even more difficult. It's going on, and I fear that most of the conclusions will be of the kind that maybe our capacity of modeling interventions was not completely satisfactory, because we have not been able to foresee what would, or at least even if somebody foresaw it, it apparently didn't work out because many countries opened too soon or too late or whatever.
I suppose that, I mean, I agree with you. I mean, I was looking back at the 2015 papers, and the one, I thought there's quite a lot of overlap with things that we mentioned, but the one area we didn't, I think there isn't very much overlap in terms of what we've written so far is the network epidemic models. And I think quite a lot of that relates to intervention and our ability to predict what intervention is going to be. So I wondered whether we should try and expand that.
Well, that's sort of, sorry.
No, go on.
I was only saying that links into this challenge from the stochastic paper last time as to whether the classification is into sort of global and network and metapopulation and spatial and all that, whether that's sufficient for the range of contact structures that we now have, and that all might fit together in a little bit of a, you know, a parcel.
Yeah, no, I wondered whether we sort of either recapped that classification argument that they make or discussion they have, or try and expand on it as well. But yeah, I was just going to say to GMP that I guess the question that I guess Hans would have is, are the difficulties from COVID really related to our ability to represent structures in models, or are they really more related to our ability to parameterize them. And so what's the modeling challenge, I suppose, is what we need to draw out. I think there definitely are modeling challenges, but perhaps we don't identify them clearly enough at the moment. Hi, Daniel, by the way.
Hi, how are you guys? It's
Hi.
6 in the morning here. So
Yeah,
sorry.
So, I mean, my feeling is that the sort of the key task, or the task that I think is most difficult, is just deciding what papers we should reference between now and 2015. We kind of almost just need to sort of pool our collective kind of random trawling of papers since then, and just sort of pull out ones that we think we should, we should reference, because I guess, what Hans detected was a sort of gap in time.
Well, another question that we might discuss just 1 minute is, has agent-based models solved everything? Because that was one of the hopes, that what theory could not, in some sense, completely understand, could, however, be compensated by very detailed agent-based stuff that was fed with all the demographic data you could imagine, and other data, etc. Has that worked? Has anybody seen something very successful based on agent-based models?
Yeah,
It was not done with a simple multi-type model. Or...
I mean, a lot of Jasmina's comments, I think, were around the fact that when you use agent-based models, it kind of still leaves a lot of issues. So in principle, you can represent things, but then in practice, I think she was talking about with vaccination, for example, that because you don't know how the vaccine works, and you don't know how effective it is, then you have a large parameter space you have to sort of search over, and so maybe there are still kind of questions for more sort of theoretical questions that could be.
Which means that agent-based models could solve everything, but we cannot parameterize them correctly or something like that.
Yeah.
Or too uncertainly or something like that.
Yeah.
I guess you might also be, in trying to put the kitchen sink into agent-based models, you might be putting in detail that you don't really need, and you're and therefore giving yourself a lot more parameters to estimate that.
Well, it also contributes, as in regression, it contributes to uncertainty all over your prediction if you leave in too many non-correlated variables.
Exactly.
They shouldn't hurt in average, but in variance they do, in some sense.
Which I guess comes back to the theme we had at the very beginning, which was to try and make a case for mathematical analysis to sort of guide us through, because otherwise it's there's too many uncertainties really in reality to sort of model.
But would any of you kind of say that in this this COVID period, there is a kind of success story for models? Or has everything that has happened really been practical politics, that if things go bad, you close down things, and then when people protest, you let them up, but then you say it's going bad again, and then you close them. So is there a success story for modeling in this COVID business?
I'm afraid that we are not that successful, like the countries which seem to do best in are pretty much using the sledgehammer and not the models, I think. Even countries which have a good modelers, like Norway, I would say they don't rely on their models.
I mean, but maybe that's just sensible, right?
Yeah, but
it'd be even scarier if they decided there was one model they wanted to rely on or everything else.
No, I guess that most modelers I've heard, but that's the same with virologists or most scientists have been pessimistic during this COVID period, saying that you're at risk if you open up too soon, etc. And that has, in a sense, maybe been shown to be true in some countries, that they have opened up too soon and then a new wave came out. But that seems to be common to almost all scientists against all politicians or something like that.
Yeah, I don't know. I mean, yeah, it's really, I mean, that's a really hard question, isn't it? And probably one we can't really answer for quite a few years, but
It might be too soon. Yes,
it
we're in
seems
the
to, I
middle
mean,
of
it seems, I mean, my reflection on this is that, you know, early on when the Ferguson model was saying that there could be like 500,000 deaths, you know, there were lots of politicians and papers saying that's insane, that will never happen. And yet we have already, despite all the restrictions, had, you know, over 130,000 deaths. So in my mind, that at least sort of suggests that they were on the right track.
Yes, and in the world, it's not finished, apparently. I still read that there are new surges in various countries here and there, in South America,
Yeah.
in India. I still don't understand what is happening. So the thing is not finished, and I think that the world number is around 1 million by now, right?
Yeah.
Dead people.
And that's 3.5 million, says Worldometer. But
3.5 million have died. Is that the latest?
yeah, and that is only the official number. So I cannot imagine that it's right for many African countries or even for India, which has high numbers.
On the other hand, I mean, all the simplest SIR model says that a disease that seems to have a naught around 3 should infect 80-90% of everybody.
Yeah.
And if then 1% of these die, then this is more or less the result.
Yeah.
No, I don't know if we need these discussions to write the paper, but
I mean, I guess fortunately we're not writing the paper to convince non-modelers that modeling is useful. That's a different. I think that's a different
kind of business, right?
Yeah.
But
I mean,
anyway,
I still, you know, I think the fact that lots of countries that initially seem to be doing quite well, like Japan, are now having much more trouble. You know, again, that suggests that there's a lot of subtleties there that, you know, aren't captured.
I guess that once again, it's kind of a common sense that you can't protect yourself against the disease by closing the country and trying to get at whatever has come in already. And then you're free until you feel the need to open up the country if the disease is still around. And that's what's happening, I guess, to those that were initially successful. As soon as they relax a little bit, then it can come in again, and then. And there are people who, of course, are saying that we will not get rid of this until we have vaccinated the whole world, more or less. And maybe not even then, if new variants have arisen by then.
I guess the problem in all these cases is
Ciao, Lorenzo.
Hello. What these things mean. Getting rid of this is as a public health problem, as at a level of reaching the same kind of public health issue that is represented by any other infection like seasonal influenza or stuff like that. That's the first. Yeah, it always depends on what the meaning of the words is, in my opinion. And the same thing, like, it's obviously if you reopen and you reopen too soon, you might have a problem. There was a discussion before, but I mean, the problem here is that what is the objective function? What's the goal? An epidemiologist, for which the goal is also only not having cases going up, then the best solution is to kind of stay permanently in lockdown. That's pretty obvious.
Cool the world. I come from veterinary science.
Sorry.
Cool,
Yeah.
cool
Yeah, exactly. And so a politician is going to try to reopen because there are other that are not only keeping the cases low.
Yeah.
I apologize. I haven't managed to reread anything about the paper and not even the email trail. But I was wondering what's Is there any specific goal for today's meeting?
Well, so what I think would be the most useful thing that hopefully is achievable, maybe not now, but over the next week, would be like if it's like everyone could send in like say 3 papers that have come out since 2015 and before 2020 that they think would be worth referencing in this. I mean, that's a small goal, but if I think if everyone did that, it would be quite useful in my opinion.
Okay, so we go on the line that at least part of Hans's comments were that we have to relate more to the 2015 papers and say what has happened since then.
Yeah.
Is that the main line, that we should concentrate on this?
Well, yeah. So, well, I think there are 2. So I think that's a big part of it. Is just that we've got a gap in our referencing, and then the other part is whether we want to slightly modify what we've said in that. I mean, for example, if we could evidence what we've said are challenges and that remain challenges by saying that, you know, the things that have come out between that 2015 and now haven't really moved things along, then we can we can justify why these things are still challenges, and we can also talk about why they're challenges in terms of COVID, which I think we do, but maybe we want to just reread it and make sure that we are emphasizing that. And then I think possibly there are some areas where we might want to have a slightly different emphasis. So as I mentioned, like what, you know, the network epidemics paper from the 2015 challenges, that was the one that struck me as having the most challenges that we don't mention. So sorry, that's a terrible way of explaining what I'm trying to say. So I went through and tried to see which of the challenges of the other papers in 2015 we kind of touch on. And for most of the others, there are quite a few, I think, that we touch on. So for example, you know, in the deterministic models, they talk about time varying infectivity, which we do, multi-strains, which we do. In the stochastic one, there isn't that much, but there's this idea of classifying models. And there's also, well, actually, maybe I should just share my.
I also wouldn't trust that paper about networks. That's crap.
I thought the lead author was quite good on that, actually.
Oh, sorry, I hated him.
but it does I enjoyed it. It does mention quite a lot of things that we don't mention really at all, I think. But
yeah, no, that's a good point. But my question, I guess, is,
hi Ben,
do we need to? So what's the problem with the paper now? It would have been helpful if I had read Hans' emails and your comments. Is it that we are repeating a lot of stuff, but it's not clear what we are repeating and what not? So do we need to remove the stuff that is already appeared until 2015, or do we still need to kind of flag it up, but make very clear what is still an old challenge and what is a new challenge?
Yeah, I think the latter. So I don't think it was saying that none of the challenges for 2015 should be mentioned, but that we should make it clear why they're still challenges. And I think
or how they've been addressed if they have.
Yes, exactly. Yeah, and yeah, I was going to say, because I think he felt that we hadn't really touched the literature very much between 2015 and at least the beginning of 2020.
On this last point, I think it's very valuable, but Valerie, would you really kind of mention this was a challenge in the past and we now have partially addressed? Well, I guess you can phrase that as we have done something, but we still need to do more type of attitude. Yeah. I was just wondering whether we want to take space to say this was a challenge and we've now solved it and it's not a challenge anymore.
Yeah, I mean, we probably don't want to do that because then we can just, it's not a challenge, is it?
Yeah, exactly.
I mean, I guess because the other thing I read through the science paper again, and I realized that reading that, you know, that again touches on lots of things that we talk about here, and I guess it's just that I can understand where Hans is coming from in the sense that you really want to know what's moved on and what this paper is bringing to it that those 6-year papers 6 years ago.
What's
Did-
new?
I suppose. Yeah, what's new, basically.
And then there was the question of overlap, however, with other papers in this.
Yeah, but we've kind of agreed to. I mean, we can talk about that a bit, but we kind of agreed to sort of park that until we knew a bit more about what the other papers, what the shape of the other papers was going to be, and so I think we agreed the focus today would be on this sort of the gap between 2015 and now. And then,
Okay. So shall
Yeah,
we take a week and try to once again go through the recent literature and see what has been done since then? Get a more definite opinion.
Yeah, I mean, what we could do today is try and narrow that down and say, let's try and do it in particular areas. So that it's, because as Valerie pointed out, it's a bit of a hopeless task to try and go through the whole literature between now and in the last 6 years. So maybe if we could identify particular areas that we should have another look at. I mean, in particular, Hans's comments were sort of about this were directed at section 6.1. So,
Yeah, that's the kind of historical and introduction and background.
well, no, that's the section on sort of the household models, the sort of spatial models, and the sort of modeling behavior and intervention.
Yes, and I guess he was saying in some of this that we're relying on references pre-2015 quite a bit, and I mean maybe nothing has happened since then, but maybe it has. Maybe we should be using the 2015 challenges and subsequent things rather than going back to the 1990s or whenever some of our references are from.
Yeah, he didn't seem to appreciate the sort of historic kind of element that we had, particularly about the development through sort of the AIDS epidemic and so on.
Although they were there just to show a general principle.
Yeah, I mean, I guess that's fairly short.
Real events and diseases kind of make modeling progress and vice versa. No, not completely vice versa. Anyway, the point was something like that various pandemics had made modeling progress because new questions had arisen.
Yeah, which I think is valid. I mean, I guess the other point is we don't have to do everything that Hans wants us to do. So it's a kind of, we should take on board what he's saying. It's useful, but we could decide not.
So do you say that we had some references that were past 2015, but we didn't make clear what was covered about from the challenges in the 2015 papers? Would this be right?
I think there was no reference to the 2015 papers in the first version, was there?
No, well, there were some, but perhaps they were a bit crudely done.
I don't think they gave very much detail, did they?
No.
I mean, they were just sort of
So
saying they were there.
So I think that element can definitely be expanded, but I think that's relatively straightforward to do.
I think quite a bit of it could be done. It's not easy to do, but it doesn't require large amounts of writing. It just requires a few paragraphs in the right places to cover some of these issues.
Yeah, so the references are there, right? And then we could do some rewriting. Is that right?
Yes.
Okay.
Yeah, I haven't done a detailed look at when our references come from. But I think a key point from Hans was that, you know, what's happened between 2015 and now, or 2015 and early 2020.
No, I mean, we can write. First, there was Daniel Bernoulli, and then there was the Isaac Newton meeting in 2015. I mean, we could shorten history.
So these two key events.
Just put in one reference or two with historical overview.
Yeah.
I think we have that with the Nicolas Bacquer.
Yes, that's kind of fun because it has several episodes of modeling in it.
I honestly think if we addressed in the body of the paper, we addressed this question about, you know, what are the challenges still, and are there any new ones since 2015? I think that's probably the most important thing.
Of course, ideally, such a chapter would be something like that. In 2015, the main challenges were said to be this and this and this, if we could summarize it in some way. And since then, progress has been made or not, and new challenges have arisen. I mean, that would be nice if we could write that, but I don't know. Valerie had tried to see how many challenges there were, and there were 20 something.
Well, I mean, it's 5 papers, so I think there are a lot of challenges. I can't remember what I said it was.
34.
34, yes,
34.
too many. But, you know, when you look at them, for example, the whole sort of spatial thing comes in all 5 of the papers, I think.
Mm-hmm.
You know, whether we're talking about deterministic, stochastic networks, fully spatial or metapops, they're all mentioning sort of addressing sort of spatial modeling in some way or other. So, you know, maybe we can bring things together by sort of picking these common elements, this whole idea of time varying things, non-stationarities and so on. They're sort of, so there are some common themes. And I think maybe, if we can try to pick up on those, and draw them together. I mean, Peter, or many of you probably know a lot more, but I don't know really what's been going on with networks. I mean, there's a lot of work that I do know about that's about modeling networks and properties and fitting and all that sort of thing, but not so much, at least that I've been seeing, on actually processes running on networks. But maybe that's a side that I just am unaware of.
Perhaps I'm too harsh on this, but I don't think we have made much progress in the past 5 years. So yeah, there is some nice stuff going on repeated epidemics, perhaps, on networks as well. Some more understanding, but really we still work on our nice networks, which probably, as John P. like to say, are typical networks in their class, but the real world is definitely not typical. So,
I mean, maybe that's just all we need to do is kind of have some brief sentences like that say that, you know, some progress has been made, such as blah blah, and then, but actually in reality we still haven't addressed what this paper was talking about. Which was that we need to be able to deal with real world networks, you know, if we're going to say useful things.
Yeah, Lorenzo, do you have any more ideas on that? You were the first author there.
I stopped doing everything after that paper. I don't have anything else to add. I haven't really been following the literature that much. There's been like quite a few groups have worked more on like pair approximations and stuff, but nothing that really, nothing that from a theoretical point of view in terms of epidemics on networks, it seems to have, and not anything that I've seen, to be honest. Maybe there was this observation that appeared in another paper where you were involved, that, as you're saying, with repeated epidemics, once you run the first epidemic, then it kind of seems to immunize the part of the network that is more easily reachable, and which is also the one that for the second epidemic would seems to be immunization due to an epidemic seems to be very efficiently distributed on the network in case of another epidemic. But apart from that sort of arguments, I haven't seen much. Sorry.
Yeah. I mean, I guess this kind of thing could point to some of this work in, what they call urban analytics that Mark Birkin was, I think, presented on. Which is kind of it's kind of, again, it's like this question of, are you going to go for a tractable model, or are you going for an agent-based type model to understand these interactions? And maybe that is a message we want to get out, is that there's a gap between the kind of models that people want to use or are using in real world epidemics and our theoretical understanding. I don't know, maybe we feel that maybe a message of this paper was that somehow we need to close that gap by sort of, maybe more targeted kind of simulation models that are like, trying that are designed to address a particular question more, rather than just a general model that can do everything. And then also, on the one hand, on the other hand, progress in the theory in towards the direction of those kind of simplified agent-based models. Something like that might be something we could identify as it's certainly challenging. Whether it's doable, it's another question. But
yeah, I was planning to have a bit more a look at the spatial things and the network things, but I'm not sure whether I will find much. We don't say much in our paper. We don't say much about spatial epidemics anyway.
no, so I presume you can all see my screen. So the yellow ones are the areas that I think to some extent from the challenges in the previous special issue, and then the green ones are ones that I think we probably should be mentioning a bit more, and we kind of do touch on some of these. So the section that Dennis wrote sort of touches on some of these issues, spatial models, but I think we did talk about trying to expand that.
Yeah, I was at some moment interviewed by someone from the Spiegel in Germany on how they read our old paper on percolation, and one thing they thought is whether control measures actually could bring us from a more global spread model to a more spatial percolation model.
Yeah.
And that is one thing which really is relevant, I think, and not well explored yet.
Yeah.
But
I mean, certainly what we found when fitting sort of models is you kind of needed some sort of level of spatial heterogeneity. You can have an outbreak in one place and almost nothing going on somewhere else.
Yeah, it's not just heterogeneity, but how do you model it? The spread. Does it have? How important are the local contacts and how do you spread between cities or?
Yeah. So one of the things that we found was that there still seemed to be quite a lot of contact between cities, despite it being a lockdown.
Okay.
It still seemed to be quite a bit going on.
So Glenn, after these, it's spatial models, and then
Yeah, that's that.
So then it's more like methodology. Do you have to cover those? No, right?
No, it's really these 5 papers
Yeah, these.
Going
Sorry,
up.
these are. Yeah.
that we thought were where there was the real overlap. The methodology and so on will presumably come up more in the estimation paper, for example, I guess.
I mean, I guess the difference between spatial and network. I mean, I think these papers sort of meant to discuss that as well. But the difference between spatial and a network model is a little bit artificial in a way, because we there are definitely spatial aspects in human populations, as well as kind of aspects which are perhaps not very well described by space, or are better described by social space, or however you want to phrase it.
If I can jump in, now that I read challenges for spatial epidemic models, I think the issues with the scale of the modeling and the intervention is quite well covered in chapter 4, in the intervention chapter.
Okay.
So I'm not sure if it's suitable to repeat it here. I think that chapter covers the issue of the scale of the modeling and the scale of the intervention quite well, both spatially and a social structure like households and so.
Sorry, it does cover sort of spatial and household.
Yeah, it talks. So chapter 4 talks a lot about the issue of tuning the scale of the model, like of the modeling framework, with the scale of the intervention in practice, and this is done both for spatial scales and social. I say social structures like households. It is mentioned there. So
yeah.
Just maybe we can mention it in this chapter, but maybe we don't need to go into deep detail.
Yeah.
Just a thought.
Yeah. No, yeah. I think you're right. But yeah, I did read chapter 4 this week, and I did think that there was quite a bit of overlap. But I can't now remember exactly what. It's not very helpful. But I suppose that the thing about spatial models is that maybe there are sort of theoretical challenges mentioned here, and then reference the more practical challenges to chapter 4.
Yes, it might be that we need a discussion, more discussion in ours, which could be referenced from the interventions.
Yeah.
So more of the sort of generic aspects here, perhaps.
And I think there was quite a lot in chapter 4 about the response of people to intervention and to the epidemic, which maybe means we could drop some of that from this paper. So it talks about the challenges of things like, the fact that people might have, so different populations might respond to, say, a lockdown in different ways because they have different needs and sort of abilities to work at home, for example, is one of the things it talks about. And we do touch on that. I think Dennis mentioned that as well, and I haven't quite decided in my own mind whether I think we should cut a lot of it from this paper or whether it's still worth mentioning.
My feeling when I was reading the 2 chapters, the feeling I had was that this modeling paper is more specific on the mathematical aspect, while the other chapter is a bit more descriptive. That was the feeling I had. So I wonder if that could be an interpretation. of how to put here and how to put there.
Yeah, I definitely think that's what we kind of want to aim for, so that here we're picking up on, our audience, maybe it's slightly different, or but we're picking up on more technical issues that relate to these other things. But okay, so in terms of proceeding,
Yes, we need some kind of strategy to get out of our current depression.
yeah, that's very true. So I still think that sort of, maybe we should focus on the network and spatial aspects and try and throw into the mix just some thoughts about what's been done more recently, even if we think ultimately that not much has been done. But if we can say not much has been done, but this has been done, but it still leaves a big gap, I think that would be quite useful. But I think that isn't necessarily a big job, really. It's just maybe only needs 1 or 2 examples. Then it would just give the impression, it would give a much better impression that, yeah, we have considered what's happened in the last 5 years, and in reality, not that much has changed. And from COVID, we've learned, X, Y, Z, and so we think that this is still a challenge.
There is, of course, yes, there is, of course, the answer that maybe on a certain topic nothing has been done because it didn't need to be done, in a way, or something like that.
I mean, I guess people's focus changes, by external factors affect what people think about.
I guess there's the other point that Jan-P raised, though, that can we say, are there new theoretical challenges that have arisen that we're now aware of coming out of COVID pandemic? And, can we add to that in a way that, I mean, I guess that's what we're already trying to do, but I think it's the way of presenting it, really, that.
Yes.
Yeah, no, I liked the idea of kind of maybe in the introduction trying to say something like, 5 years ago there was this big program and this special issue, and it raised all these, we have to focus on it, but as far as we're concerned, it raised these really important challenges. And then, this paper, we will review what's been learned in the last 5 years, and sort of and maybe at the end we then come back to that and say what.
I don't know, from a point of view of walking around in the street and seeing everybody still with face masks and things, should models incorporate people's kind of natural reactions to epidemics and pandemics, for instance? Because all our basic models don't incorporate them. They kind of suppose that people go on acting exactly as in the beginning, and therefore 85% get infected.
Yeah.
And that's it. So
I think that we sort of do have a section on that, but it's been toned down, I think, to include more, more intervention. But again, the question is, I suppose, what can we really say about, how do we do that? I don't really know. I'm not sure how many good answers there are out there.
We don't necessarily need to say very much how we're going to solve these challenges.
True.
That's the usual comment that I received when I was making similar comment. This is obviously extremely kind of it's extremely biased view, because these are just the things that I remember having worked on. But since 2015, contact tracing has gone further, even from a theoretical point of view. There are a couple of papers on the branching process approach, and there is a paper by Francesca. And I was one thing that appeared during this pandemic is that I haven't really worked much on in the past is when you try to do things that involve real time. Most of the mathematical results are fairly they focus on reproduction numbers, final sizes, and this kind of concept that are time integrated quantities because they're just mathematically easier to handle. I'm not really sure how many theoretical results you can have for things that really change over time, apart from just integrating ODEs. And this is probably why much of the more applied models are simply ODE based, because you want to solve them in time somehow. So that's kind of cheap and convenient. It is somewhat something that was probably quite badly trying to flag up in the household section, but then because everything was too long and those thoughts were not really thought through very, very well, I think they were dropped, which made sense at the time.
I mean, I think there is a statement to that effect about most theoretical results are kind of time integrated type results.
Yeah.
But yeah, maybe we just need to revisit that and sort of draw that out a bit more and make it very clear that this is still a big challenge, isn't it?
Yeah, I guess that it could simply be that they've always been challenging, and people have always used applied models that were not mathematically particularly innovative. They were mostly sets of ODEs when trying to do something practical during an outbreak, say, I don't know, Ebola or previous pandemic influenza. But the question, it would be nice if there was more theory out there with this, but I'm not really sure even how many theoretical results are possible with
No, but what's then the problem with the time-dependent results, since we can compute them usually?
Yeah, but then you can also compute the final size by just making some ODEs and just let them run, right? I think the usual problem of having analytical results, it's helpful for two reasons, in my opinion. One is it makes more transparent the dependence on the model parameters. It's instead of kind of changing the parameters and running the epidemic again, you have a formula that shows the explicit depends on the initial parameters, if you have anything of that sort. Or at least if it's not that explicit, like, for example, I don't know, R naught being a dominant eigenvalue, you have some properties, and you can kind of change many parameters quite rapidly and recalculate the dominant eigenvalue. And so exploration is easier. This is point number one. And point number two is that when you have something that allows fast computation, that really opens up the door to parameter estimation, where you need to kind of calculate likelihoods and do really many calculations of those quantities. If it takes time to do that, it becomes prohibitive due to kind of lack of patience, really. These are the two main reasons that I've always kind of felt, for which I felt analytical results are very valuable. The third one is that trying to find analytical results that are general and so on just forces you to be very clear about your assumptions and highlight whatever knowledge gaps you have, that when you kind of do simulations, the knowledge gaps are still there. You just hide them under a pile of extra thing that you just put in your simulation because you can. So you don't fundamentally solve the issue, but it's more hidden. These are the three things that where I feel analytical results are very valuable.
No, it could be fun, because we'll have to go back to 19th century math and dream up a class of special functions and then study them so that we can characterize the solutions analytically. It could be fun. Effectively, ever since the Goncharo polynomials came up, I've been thinking about that, but no, it's true. There's something missing there, that once we kind of saw that it's difficult to write down a formula for the main function in the SIR epidemic, we have let that be. And then said, okay, it's difficult, we don't do it. And we simulate instead. So, okay, that's a challenge maybe. A better analytical understanding of how these models, especially multi-group or whatever, how they really behave.
It's just a thought, but maybe it's a thought that is simply driven by the fact that.
No, but we have our Italian colleague Andrea Pugliese, who tried to write a couple of papers of what happens if you have these multi-type epidemics and you sum them, you just see the results. How does the epidemic that is seen, which is the sum of all the multi-groups, how does that look? That's an interesting analytical question. Right? And we don't know very much about it. It has to do, as you say, with all the eigenvalues suddenly and how separated they are and whatever happens.
It's not a major point, really. I think it was just one thought of something that that this pandemic has brought to the forefront, I think, just because it's lasting for so long and it just keeps on going and nothing is really steady at any point.
Yeah.
But that is our interference with it all the time.
Oh yeah, absolutely. But and it's also absolutely possible that it was exactly the same during the 2009 pandemic and during the Ebola outbreak and SARS-1, and it's just that I wasn't really doing much like the stuff I'm doing now, and so at the time it was like I'll apply some models to past results, or I'll use some concepts from these models, and that's it. And now it's a bit more. Everything is changing all the time, and I try to do something rapidly. So it could simply be a reflection of the different role I'm having at the moment, if you see what I mean. But I feel like many of us are also in a similar situation. Many of us are trying to do something on COVID, and COVID is continuously changing.
Yeah, the questions keep shifting.
Yeah.
Oh yes, there are plenty of good questions. I mean, all the newspapers right now in Italy are kind of optimistic. They say the disease is going down quicker than expected thanks to the vaccinations. Is it really quicker than expected? Has anybody of us expected something that it would take a longer time? That's a good question, because it is going down. The deaths are going down quickly, not the new infections that they find, but the deaths are going down.
Well,
or is it just newspapers?
Yeah. Can I throw in my question relating to that? Is why, if you see the number of infections in Europe, then both the Netherlands and Sweden score very high. So they have very high levels of infections per inhabitant. Why is that not shown in the number of deaths? That is my question at the moment, which I am not sure. It's not that the Netherlands and Sweden do better in vaccination or anything. So
yeah,
they have a very low infection fatality, or no case fatality.
No, the Italian authorities are communicating now and then that the average age of the newfound cases is going down.
Yeah,
but it's still something like 40 years, I think, the last I heard some time ago here. So it's not completely young, but it's still much better than before, when the average age was 70 years or something like that in the beginning. But of course, I don't know if that's the only reason that the age profile has changed. Of course, that with differential mortality should be at least one part of the explanation, but maybe something else also is going down.
But that should hold all over Europe, not just in some specific countries.
Yes, but then you have this population attitude, I guess, to going about daily life, trying to measure that, if it's more relaxed in these two countries.
But that's not in the paper, I think. And then the suggestion I was toying around a bit is that the Netherlands and Sweden are also the countries with the highest average, surprisingly highest average vitamin D in the blood, also the least vitamin D deficit.
Greatest deficiency. Or...
The lowest deficiency.
Minimum deficiency. That's interesting. Yeah.
Oh, okay.
Because the Swedes put it in all. They are so afraid of it. They put it in all food. So if you drink a reasonable amount of milk and eat a reasonable amount of fish, then you basically don't have to go outside. Which But yeah, that is not related here, and not what I think it's very interesting. But
it's also the only two populations that like to skate on ice, as far as
the Norwegians.
Yes, the Norwegians.
But they don't get. They don't get infected in the first place, and that's. But yeah, let's go back to the paper.
Okay, so Glenn suggested that we kind of decide on maybe dividing up a little bit, doing this first story research from 2015 to 20 on various topics, so that we have something more precise to say. Shall we divide it up according to the 2015 papers, in some sense? You had this list, Glenn, up on the screen, showing the various papers and their...
So, I mean, this is quite a partial, I mean, it's a complete list, but it's a partial interpretation of what these things are saying. But so, yeah, the deterministic challenges, I think quite a few of these things we can sort of dismiss, in the sense that, you know, maybe we can just say we're not interested in endemicity at the moment. At least we can, I mean, clearly it could be a problem, right? So, but we haven't thought about this in the paper so far.
Is there not also a specific paper on endemicity, number 5 or something?
Yeah, number 5 is supposed to be that sort of endemicity or elimination, isn't it?
Yeah, so we can leave that.
So that gives us a reasonable excuse, at least. But although, if we apply that logic, then we could just not give up.
I'm not sure they'll be thinking about
yeah, exactly.
it from a mathematical perspective.
Yeah, exactly. So there obviously are lots of interesting questions that we could get into, but we haven't thought about those at all yet. So I suppose that is a question then, isn't it? We also haven't thought at all about a CEPA infection. We've kind of touched on multiple strains, which I guess relates to that, but we haven't thought about more than multiple pathogens. So these two in yellow are kind of ones that I think we do kind of cover to some extent.
No, maybe, I don't know very much about all these models, but maybe there's something about these variants of concern, because that means that you have populations which have different levels of protection from previous infection or previous vaccination, or none at all when new variants come in. And I don't know how much has been formalized of this thing, that you have waves of new variants coming in almost during the same epidemic. And I guess that some of this is covered. I mean, was anybody shocked by the invasion of the British variant that suddenly substituted for the other ones in what, a month or so? Was that foreseen by our models for competition between variants?
No. I mean, it's not foreseen, but it's quite understandable, I guess. But
the main problem, I think, in my opinion, with those is that there are many models of competition between strains, and most of these models still talk about, again, not necessarily focusing on real time. It's mostly about the strains with the largest R0 wins in the long term. But in the short term, it's completely different. And then if you put that in a stochastic model, the other strain might get extinct, and that sort of stuff. It's also very unclear how much immunity there was to the previous variant before the Kent variant arrived. And therefore, it's not really clear whether there is real competition for susceptibles, or we are still in the early phase where the two are just moving independently. Because it's not even clear whether they are kind of spreading in the same part of the network. For example, healthcare workers and other individuals that still move out and about during a lockdown. All of this is into a context of changing background change in transmission rate, which makes everything much more complicated. So there are many models of multiple strains, but again, the analytical results tend to be focused on what you can actually do analytically, which is steady state behavior or extinction of one versus the other. And they are generally simple models in the sense that you make some assumptions about how one strain gives you, partial protection to the other. Infection with one strain gives you partial protection to infection with the other, or assumptions like that are you can make, but then in reality, what happens really depends on the particular context, and obviously the outcome of the model depends on those key assumptions that are often just made in many cases by mathematical convenience. For example, if you assume that two strains can co-infect the same host, unsurprisingly, you see coexistence at the population level, and that's not surprising if you've made an assumption of coexistence within each single host separately. What I'm trying to say is that there are models with multiple strains. They tend to be rather simple, and they tend to be focusing on the long-term dynamics because they are easier to handle mathematically. And then ultimately, whether one variant overtakes another, that depends on the characteristics of the new variant. A model could predict it. You can just say, if this model has a larger R0, it's going to take over, for example. That's a prediction of the model. But the point is this new variant, does this new variant have really a higher R0? And as soon as you see it taking over, you're like, well, clearly it has a higher transmissibility, or at least a shorter generation time, or something else that just kind of makes it.
It's about Malthusian partly, right?
Yes, in terms of, that's my point in terms of time. In the short term, the one that grows faster wins. In the long term, the one with the largest R0 wins if everything else in the model stays constant over time.
And as you were saying, if you have the more transmissible one, then in the long term, this one will win. And usually these models will show that the more virulent one will not prevail. But if you do some analysis in the transient analysis in the short term, this could have an impact, and this is usually not measured by these models.
No, but your assumption is that you have some kind of SIRS or SIS, right? So you, if it's pure SIR, then...
Usually simple models with these two strains with different parameters.
In the SIR, the quicker one is quicker.
Yeah.
If it's not very has a high R, then the other one will come up later. So
Yeah.
and then it depends on the degree of immunity that the quicker one gave for the second one. It's
But so here there is some confusion. I consider SIRS and SIS complicated models, not the basic models. Well, they are basic, but not simple.
But then you have the kind of development side that, of course, a variant will not be taken up for consideration if it is not stronger than the previous one, because that's the only ones we see. There are many failed variants probably around that we never see.
No, but so my question is, can a variant so is it only about R naught, whether a variant can immigrate in a population, or is that also about the Malthusians?
No, it's also about quickness. I mean, you have these two things that you have beta minus mu, and you have beta divided by mu, and these two things can behave differently. So one can be quicker but weaker and whatever.
My understanding as well is that there are sort of complications that come in if you consider like quantitative genetic aspects. So, for example, the thing about, you know, whether you end up with low or high variants is partly determined by the sort of mutation landscape that you're on, and so that complicates things further. Obviously, presumably that depends on the precise pathogen.
And then you have us complicating the stuff by our interventions that will select.
Yeah, we should stop those interventions, I think.
In a way, yes. If we are afraid of variants that are difficult to do something about, then we shouldn't intervene so much. But that has been said for I don't know how many years about antibiotics. Using that's different schools, but
I guess the other option is to do multi-interventions that are very hard for it to escape.
Yes, that's the HIV story.
Yeah, and I think there are similar ideas with antimicrobial resistance as well. But that's maybe for another day. So anyway, so we do have so these ones in yellow, we do have some text currently that touches on this. I'm sure we could expand it and link back to these challenges maybe. We should be doing that. I thought that there wasn't much that we touched on from the stochastic models with global transmission from the previous one, but we already mentioned this idea of this classification that they talk about, so that's maybe something we should add into the introduction. They also touch on persistence and endemicity. They talk a bit about this near critical behavior, which I don't think we kind of, we don't talk about it in our paper at the moment. And also epidemics in growing populations, but I thought that probably isn't particularly relevant, but maybe.
No.
And then they do talk about mutation and evolution, which we've just been talking about. So I think that's kind of covered. And then, as mentioned already, the network paper, I think, is the area that we have at the moment very little explicit kind of discussion of these challenges that they identified. And some of them maybe are not that relevant. So I mean, I don't know to what extent it's not quite clear to me to what extent we should be talking about parameter estimation in this paper, because I think there is a case for it, because I don't think it's really covered in the estimation paper. I mean, that's much more on the technicalities of how you do estimation, whereas I kind of feel that the questions of model structure and estimation should come in our paper here. I'm not entirely sure why I didn't highlight this part number 2, but I think probably partly because yeah, maybe that should be highlighted as well. But I guess sorry, Peter.
I should have a look at that. That might actually be something which has been done quite a bit on by Joel, for example. But I don't, but Joel Miller, but I don't remember whether it's what the exact challenge was in that when we wrote it.
Yeah, and then it goes on to talk about dynamic weighted networks, which obviously are, as far as I understand, are still very much a challenge. And I'm not aware of that much that's been done on that.
Something has been done on that actually. I can have a look.
Okay, great.
Not much, but something, yeah.
And then, yeah, it also talks about waning immunity, which I think essentially means an SIS and SIRS models.
Yeah.
In that context.
I can assure you that's still a real challenge. And people who solve it usually have it wrong. There have been papers on that, but they make approximations which basically ignore why it is a challenge.
But that's because you think of repeated epidemics on one network.
Yeah,
one fixed network.
Yeah, or even changing, but it's still so that the immunity stays clustered in some way, and that makes it hard.
Yeah.
Even if there is waning immunity.
And then I think to some extent these are kind of linked, but I think possibly going back to the conversation we're having about chapter 4, maybe this is a way for us to talk about interventions in this paper that would be very distinct from the what's done in
interventions in the interventions paper.
Yeah. And then, the meta population and household models chapter previously. See, I don't know why I highlighted this one as green. Anyway, so endemic models. I mean, so we already have like a bit section on this. So I suppose the question is whether you guys are happy with what you've written, or you want to sort of adapt it slightly in light of Andy's comments.
Well, also because this thing about endemic models, I mean, it's kind of different to imagine the same disease being endemic, but exactly the same disease, because it will live on kind of demographic change of the population and things like that. And things being endemic, like our seasonal flu, because we have kind of different variants all the time, but we call them the same. So seasonal flu is endemic, but it's not the same disease. And I guess that's a distinction that has to be made in how you model them as well.
Yeah.
Yeah, I guess the main problem with endemicity is that the disease spread is at the same time scale as the, if you want loss of immunity, therefore the immunity profile in the population changes, and also your population, like the demography, and
it's renewed, yes,
changes. They're all on the same time scale, so it becomes basically you need to develop a model of how households change in size, people are born, leave the household, form new households, and then have an epidemic running on it that therefore distribute some immunity in this moving population, in the sense of households changing shape and form, and then on top of it, if you have a new variant or something, like you need to understand how previous infection confers immunity to the new strain. If you have multiple strains like influenza, like
oh yes,
like Jumpy was talking about. So all these three things just make the model more complex and forces lots of assumptions.
I mean, maybe. So I'm actually thinking that maybe having something on endemicity is a good idea, because, you know, if we have pandemics, it seems very likely that it'll be hard to eradicate, and therefore we will be living with them for quite a long time. And so maybe a long-term challenge is dealing, tackling some of those kind of dependencies that you're talking about. Okay, and then so we do have a little bit about thinking about internal dynamics and sort of within host and between host dynamics at the moment, but I'm not sure how well I don't think it overlaps particularly well with what is written here, so that could be revisited. And then we have the kind of spatial paper, which I think Dennis was suggesting that we kind of tried to beef up that section that touches on some of this. So
yes, and there's an interesting side to spatial things, that we suddenly have a lot of data. I guess I don't know how many refer to Google mobility data. We know Norway has a very nice model where they have apparently all the mobile phones that move from one city to another all the time and things like that. But I don't know how much it has really explained about how disease is spread from one place to another. If there is a good correlation, because the problem is that mobility is almost everywhere in our society. So, and disease is spread usually quite well, except for faraway places. At least that's the feeling I got. So has spatial models contributed anything to human populations? They have worked apparently for rabies and foxes and stuff like that, but have they contributed anything to human populations? I don't know. I'm a little bit ignorant maybe on what has really been done. Many have inserted it in the models, but
yeah, I mean, I think a lot of it depends on what kind of questions you're trying to ask, isn't it? I mean, if you want to know should Glasgow be locked down versus Edinburgh, then you sort of need to distinguish between them. So
yes, and what would happen if you prohibited contacts between Glasgow and Edinburgh? Would suddenly the thing be halved in both places or something like that? Or
well, I was a bit surprised that with the local outbreaks in Australia and now in Taiwan, they are really local in the sense that they are seem to be mainly going around in just an area in a city, not even the whole city. That was in Melbourne the case. That's now in Taipei the case.
But is that just that they're spotting it early and we haven't had long enough for it to
spread?
Well, yeah, but in Melbourne, it was, I think we are now past the outbreak, right? Taipei it's now going on, but
Yeah.
Or else it's the result of one super spreading event of some kind.
yeah.
A little spillover from that event, and so it remains local because of that. And then you stop it, of course. Who knows?
The last question there, about the scale of intervention, it's still valid, right? And I don't think there's much in the past few years on advances in about this.
Yeah.
Yeah. And again, I think, that brings in the whole question about behavior and how people are going to respond, so if you shut down one area, are you really just pushing everyone to go somewhere else?
It's that example I have used more often during animal disease in the Netherlands, where birds were infected, that they were talking about culling birds, and only when they really had the infrastructure in place, they said that they were going to cull also the pet birds, because otherwise they were afraid that people were going to move them around the country in preparation for that to happen.
Yeah.
So they were very careful not to even give a hint that it was an option.
So did they cull the pet birds as well?
Yeah, they did in the end, in the affected area. But up to the day it was actually announced that they were going to do that, they actually gave the impression that it was not going to happen. The public health or the animal health authorities.
No, Italy has been going on for almost half a year now with regional decisions on lockdown severity, according to a strange classification in colors and things like that. But I don't know of any analysis if that has been. Of course, it has worked in the sense that where there were many infected, then they locked down a little bit more, and sooner or later it went down there. But so they had a regional scale in Italy, or they still have, but now everything's fine, more or less. So the scale of intervention is interesting. Do you gain by doing local interventions, or should you do large-scale interventions all the time? But that is coupled, I guess, very much with the economic side, that the hope is that local interventions will save the economy in other places.
Yeah, and not much about the theoretical aspects, right? About this scale of the intervention. Yeah.
Yes, it has a very evident spatial side to it, that once you notice a local phenomenon, has it then spread a lot, but you haven't seen that yet, or is it really local? It has also to do with, in some sense, undetected spread, right? There's a delay in detecting spread. And that's a classical problem. I mean, when you see a focus of disease, has it already spread around, but you haven't seen it yet, or is it really there, local? Because we tend to see effects when people get to hospital, right? And that's a little bit late from the spread point of view. So that has to do with spatial modeling and things like that. Okay. How should we go about it?
So it seems to me that we've got like 4 categories here. So network models, household models, and spatial models. And we've also got this question about endemicity. So are there any volunteers who can sort of like try and look at one of these areas maybe?
I will do my best to look I cannot. I'm really drowned in teaching coming week
Yeah,
as well.
I mean, again, I don't think it necessarily need. I mean, even the first things that occur to you might be might be useful, you know, the most useful. I mean,
But I will try to look at the spatial one at least and
Yeah.
see what can what's done. Try to get some literature there.
Okay, thanks. That's great. Thanks. And
What should I do? Look at the paper where I was involved.
I was, maybe I can work with Lorenzo. I volunteer for him. Maybe we can have a look at the household
okay, thanks.
studies.
Mhm.
I'm not sure
Okay.
if they will be happy to be volunteered, but I think so.
Yeah, that-
Oh yes, Lorenzo's happy to be volunteered. I'm certain of that.
I was thinking I'd have a look at my, you know, my sort of database of papers that I've actually downloaded and read in the last few years and see which is likely to be mainly networks and things, but it might dig up a few things on households and networks.
perfect. Thanks.
Can you roll down the list a little bit so that I remember what was on top? And the networks and the deterministic things. Well, I don't know very much about deterministic models. Maybe this is an occasion.
What's left, Glenn?
So essentially, the thing that's left is probably endemicity question, whether we want to say something about that or whether we're just going to leave it.
Yes, the endemic thing is in several places, right? You have
Yeah.
the lack of endemic stochastic models. You have endemic stuff in deterministic, and you have this question what endemic really is. Is it the same disease coming back, or is it variants that
Yeah.
are? So endemic question.
It's persistence, right?
Yeah.
Yes, it's kind of, and also the question, what is, I mean, is influenza, seasonal influenza, persistent disease? It's almost a definition problem, but to most people, yes, since it comes back every year.
Well, I guess it also kind of regenerates itself in the sense that it's not completely novel strains, is it? They're derived from the ones that
Yes.
were around before.
And that's also what generates all these kind of rather strange outbreaks, because as far as I know, usually seasonal influenza strikes, 10-15% of the population every time. So there's something, it would seem to be a very weak disease in that sense, right?
Yeah.
But it still survives and survives and survives, which is kind of strange.
Yeah.
And that must have to do with immunity profile all the time. That in reality, it's a strong disease, but it kind of has this balance with immunity profiles all the time.
Okay. I'm just aware that we're at time. So Valerie and me, I guess, will look at networks and try and come up with some references for that. Francesca and Lorenzo are going to look at household. Peter and I guess Dennis will look at spatial, and then Jan P, you'll think about the endemic.
Yeah.
I don't know. I could look at either spatial or endemicity. I'm not sure. It's
I mean, again, if you are aware of stuff that you think we should be referencing, I guess that's in whatever category it falls into. It would be useful to,
right.
You know, more recent developments.
Would it be an infringement or copyright if you sent around this list? It's kind of useful anyway.
Yeah, no, I'll send that around. Yeah.
The challenge is the table of contents, which is what this is already in the Dropbox.
Yeah.
So the only thing we don't have is
It's the
blend-
colors.
It's
My
the
lurid
colours.
colours.
Yes.
But it's in the Dropbox. It's called table of contents or something.
Yeah. Which
Then-
but I mean, you could put the coloured version
I'll
in
put
as
this
well,
in as well. Yeah.
or put it in the chapter 6 thing, whichever is most convenient for people.
Yeah. I'll put it in there. Yeah.
Then could you also send an email with the tasks just as a signpost?
Yeah, I will do.
Thank you.
Especially to Lorenzo, so that he knows that he volunteered.
I don't want to tell him.
You say it was a decision of us all.
Yeah.
That's
Francesca said you were going to do this.
And Dennis too would want that, although he won't be able to do much.
Yeah.
this week.
But he'll be back, right? He was away
be-
a couple of days.
No, he's away a week. He went yesterday. He'll be back next Wednesday, I think. But so he's he has no broadband access. So he will pick up emails and so on, but he's obviously not going to be able to do a lot of, scouring the net for things.
Yeah.
Mhm.
I want to go on holiday where Dennis has gone on holiday.
Yeah, I think we'll all go.
Yeah.
Okay, and then we'll meet again for all Lang Syne. Yes.
Same time.
But we don't have any fixed meeting, or shall we try to
Well, I think we said we would just meet at the same time next Friday.
next week? Next week,
Yeah.
okay.
Because by that time, Jasmina said she would, and I and others said we would look at the overlap with the other
Okay,
chapters a bit more.
Friday next week.
Yeah.
We have an appointment.
Okay, thanks everyone.
Good.
Thank you.
Interesting
A
discussion.
good,
Bye.
a good
Good
lunch,
weekend.
all of you.
Bye
A
bye
good
bye.
weekend.
And you too.
Bye.
Bye.
Yeah, bye.
Bye. Bye.